Well, that hole is crazy looking. Why do you suppose that is? Stay tuned to find out. Hello Internet, my name is Quinn and this is Blondihacks. I'm starting a new tool making project today. I'm going to make a pair of these can't twist style clamps. These are from a kit that you can order, and the cool thing is I have a second one of these kits and one of you is going to win it. So stay tuned to the end of this video to find out how you can win your own. The cool thing about this kit is that you can make it entirely on the lathe. Believe it or not, every component in these clamps can be made on a lathe. I'm going to use my mill for a few steps, but I'm going to show you how to do it on the lathe as well. So let's go. The kit in question is from D. Gray Drafting and Design. This is a small Canadian business up in Winnipeg, so I'm happy to support him, and this is a great kit. So let's dig into it here. It's wrapped in newspaper, very well protected, and here's all the stock and the plates and everything that we need. And it came with some nice local Winnipeg newspapers. Stock here is mostly 12L14. There's a little bit of tool steel in there, and the plates themselves are all hot rolled. And here are the drawings, which are fantastic, everything you need here. And this page here is especially cool. It shows the suggested layout of the parts within the stock. That's a common source of difficulty with kits like this, is figuring out, how much room you have between each part, and so how careful you need to be with cutting the stock apart and so on. So having this guideline is great. There's also really extensive build notes, much better than you get in most of these kits. There's suggested orders of operations and step-by-step instructions for many of the trickier components in here, so that's awesome as well. The clamp legs are laser cut, which is awesome. They have really nice edges, and the really trick feature is that they have the drill locations etched right on the surface. So it's very easy to center punch all of these. And precision is fairly important here, so I'm checking with a magnifier and moving each punch as needed. Then I proceed to punch all of them the same way. And as suggested in the drawing, I'm going to be gang drilling these to make sure that each pair of legs is very well aligned. So I deburred them, and then I'm going to super glue them together. This approach works really well, and again, it's just sticking to the suggestion in the build notes. I'm using 1, 2, 3 blocks to make sure the edges are well aligned, and then some binder clips there will clamp everything up. I'll let the super glue cure thoroughly there. Now the kit comes with a pair of clamps, so I considered doing all 4 plates of each type all at once, but the drawings do not suggest doing that, so I figured there might be a good reason for that, and I'm not going to pretend that I'm smarter than the drawing. Sometimes I do that, but not this time. I decided to clamp them directly on the table for this, so I'm just lining the center drill up with my punch marks, and this is a trick I use a lot. You just bring the drill down until it touches, and you give a little spin by hand, and you can see from where the divot is if you're on your punch mark or if you need to adjust a little bit. So I center drill this hole, and then I do a pilot drill, and then I open it up to one size below the final dimension. These holes need to be precisely dimensioned because there's going to be machined pins that need to be a really good fit that go in all these. So once I've drilled it slightly undersized, then I come back in with the reamer and ream it to a final dimension. Now this is a lot of tool changes per hole, so it would be more efficient if you could do the same operation on all the holes and then change the tool and then do the next operation. But these holes are kind of all over the place. They're not in a real regular pattern that's easy to locate on the DRO, so that's why I ended up doing it one by one. But there might be a more efficient way to do it, I'm not sure. In any case, I deburred both sides, and of course the insides of those plates will need deburring as well once they're separated, but so far so good. That's a nice looking hole. And then I had to do that, I think, 29 more times, something like that. It's a lot of holes. And with that done, a little bit of heat will break that super glue. And you're just trying to heat it up to cause the glue to fail. You're not trying to vaporize the glue, so don't get it too hot, because vaporizing cyanoacrylate has a tendency to make cyanide gas, which has a slight tendency to cause death. And a little tappy tap tap, and those come apart. And for finishing these, I decided to just buff them up on the Scotch Brite wheel. Just take the mill scale off of the hot rolled surface there. You could fly cut these or surface grind them if you have such fancy equipment, or you could frankly just leave them mill scale for durability. That would be fine too. I decided to polish them up. Now they still have the rough mill scale surface on them, so you have to take a lot of material off to completely get rid of that. So they have a little bit of, let's call it artisan flair to them, but then I was able to deburr the other sides of those holes. Next up are these bushings that act as standoffs, and they hold the two legs of the clamps apart. We need a whole lot of them, and it's going to come out of this piece of round bar. I'm just looking ahead on the drawing to make sure that I know all the parts that need to come out of this stock, so that I know, how much wiggle room I have, how precise I need to be with cutting the stock apart, and so on. So I'm going to use the collet chuck for this, and I will face off the end there, as is tradition. The build notes suggest cutting the stock into the little pieces roughly to length, and then facing them to dimension, and then adding the features. That's actually not how I would normally do parts like this. I would probably pull the stock out and support it with the tailstock, and then make all of the parts while still attached to the stock, and then cut them apart at the end. However, as I said before, I'm making an effort to not try to think I'm smarter than the drawing, and I'm going to follow the suggestions here because, someone who's built these parts before me probably knows a few things about doing it that I don't. So here we go. So I did that. I faced off one end of each of the pieces, flipped it around, faced off the other end, and then I'm able to take a precise measurement to see how much I need to face down. And to do that, I put an indicator on the carriage, and then I can face it down the exact amount that I calculated that needs to come off the part. And then I'll measure that and see how we did. I'm aiming for 997, and survey says that's 996, and on the truth teller scale, 9/10. So I am 1/10 undersize here. I think we can live with that. I'm not going to claim they're all that good, but I am going to pretend they are and not show you the rest because this is YouTube machining. These standoffs have a cap screw that goes in each end of each of them to retain the plates. So I'm drilling each one all the way through, and then I can tap each end. If I had a long enough tap, you could just tap them all the way through, which would be easy, and then you could do it all in one setup. My tap isn't that long, so I'm going to have to tap it from both ends, but I have the minimum depth there set with a tape flag. You got to make sure that the screws will bottom out in the bushing there, otherwise things won't assemble properly. So double check that that is the case, and it is. So that's looking good. Now each of these bushings has a little shoulder on it that seats on the hot rolled plate that forms the legs. So I'm going to do that on this setup before I give it up. So I'm going to zero the indicator once again and use that to cut my shoulder. All of the dimensions here have to be surprisingly precise, because if they aren't, then the plates aren't going to sit parallel, or something's going to be shifted, something's going to be crooked. So it's quite surprising. It seems like a very straightforward thing, but you really kind of have to nail all of these dimensions on these bushings, the lengths and the diameters and the depth of the shoulder and everything. The tolerance on the diameter here is +0 -2, so in that case I aim for the 0, so that if I miss it by a thou as I did here, I'm still right in the middle of the tolerance, which is great. And then on the depth, I'm right on according to the guessometers, so that's pretty good. Now I can flip it around and do the same feature on the other side. The collet chuck is really the hero of this project because it's allowing me to flip these parts back and forth and keep concentricity, and it's making it easy to hold all these parts without damaging the outer surfaces. Most of these parts use the unmachined outer surface as a nominal dimension, so you don't want to mar that up. So yeah, the collet chuck is a real hero here. If you didn't have a collet chuck, you'd need to probably do all of this in the 4-jaw because you're flipping the parts end for end. Although maintaining perfect concentricity isn't that critical, so if you had a good quality 3-jaw, you could probably get away with that. And after that, I polished them all up on the Scotch-Brite wheel because, again, the outer surfaces are unmachined, so it'll just make them look a little nicer. And here is the stock I had left over, so that's not bad. I'm going to step up to a larger collet now because I'm going to make the main hinge pin that forms the fulcrum of the clamp. And this is made from this larger piece of stock in the kit. And unfortunately, it won't fit all the way into my collet chuck. This collet chuck that I homebrewed from a Morse taper tool holder doesn't have a lot of depth to it because the back of it's not open. It's got a drawbar in there. So instead, I'm going to cut these pieces into approximate lengths for the 2 of these hinge pins that I need. So this can go in the collet, and I will face off this end as is tradition. Or not like tradition, because that tool is cutting like crap. It clearly needs a regrind. So I'll try this other one, and yeah, this is not much better. This is 12L14 steel. It is not the material's fault. These 2 tools just both need regrinding. I use them both extensively, and it's been a while. But I will suffer through with this tool for a little while, and I did regrind it here in a minute. Now these pins have big shoulders on the sides, just like the little ones did, but obviously a different diameter. Just like with any basic turning to a shoulder, on my finishing pass I go all the way in to the final depth, lock the carriage, and wind out to finish both surfaces. If you want to know the details here, I've got a video on turning to a shoulder. I'll link to that below, you can check it out. And sometimes aiming for the high end of the tolerance can backfire slightly, because on final inspection this diameter is actually a hair too large, and the drawing specifies +0, -2, and they are serious about that +0. If you go larger than that, the pin is really not going to fit well. So I did one additional very light skim there to get it down to the middle of my tolerance, and that is looking good. I still never regret aiming for the high end of the tolerance, because it's saved me more times than not. I flip this guy around and do the same thing on the other side. This is the same process I showed for the little spacer pins, just with a larger diameter. And of course we need 2 of these because there's 2 clamps. Now you might think it's really inefficient to make these parts one by one instead of doing like one operation on each as you go along, or making them all from one continuous piece of stock, something like that. And it's possible that there is a more efficient way to do this, but this is more efficient than you would think, because after you've done one, then you know all of the numbers on your dials that you have to hit for each dimension. So for those skinny little standoffs I was making earlier, I only had to measure the first one, and then after that I just went to the same number on the dial for each dimension, and they all came out within 1,000th. So it's really quite efficient once you've done a couple of them. Next up is a very similar pair of parts with little shoulders on the ends, but this time we need threaded holes through the middle of them. These are the main nuts that drive the clamps. So I start by making them the same way as the other parts. This is all straightforward, same as before. And according to my Noga chipometer here, the chip tray is due for cleaning. The key challenge with these parts is that the hole through the center of them is quite large relative to the size of the part, and that means there isn't a lot of meat to hold on to drill that hole. Now one way around that would be to leave the parts attached to the stock and drill the holes while the parts are still large, but remember that I couldn't do that because I'm using the collet chuck. There isn't enough depth in that thing for me to pass long stock into it, and I didn't want to drill centers in the ends of these parts. So instead I'm going to use this little guy. This is a cross-drilling fixture. Longtime viewers saw me build this not so long ago, and it's going to allow me to set up these parts and drill holes through them even with so little to hang on to. So I edge find on the fixture to get the y-axis center, and then I used a little gauge block to find the edges of the x. Any size gauge block works for this because I'm just centering using the half function, so whatever the block is gets canceled out. Now I can center drill and drill right down through the middle of this thing. And there is a hole in the bottom of that fixture, or at least if there wasn't, there is now. With that cross-drilled, I'll take advantage of my setup here to cross-thread it as well. Yeah, that's right. I made the cross-threading joke twice in 1 month. Deal with it. Time to fish that out of the fixture and see how I did, and yeah, that's looking good. I always found conic sections in Boolean geometry really interesting, and the way that the threaded hole interacts with the concave surface of the part is super interesting. It looks really crazy, like it looks like there's something wrong with that hole, but it's just the way the threaded profile interacts with it. And if I thread a bolt in, suddenly that confusing topology makes sense. You can see how, oh, now it clearly looks like simply a round hole in the top of a round surface. I find that kind of thing super interesting. Next is a bushing that's very similar to what we just made, except that it has flat sides. And that, surprisingly enough, changes everything, because now we cannot hold it the way that I just did that last part. So this is going to change up the order of operations, and I'm going to do it the other way that you might consider doing parts like this, which is to make both of them with the stock still attached. And because I need 2 of them, I'm going to make one on each end of the stock, and that's going to leave stock in the middle to hold on to for the various operations. So I'm going to start by drilling this all the way through to a depth that's sufficient to cover the entire part once it's parted off. So I've measured that depth, and then I'll thread it all the way down the same depth. Luckily my tap is just long enough that I can thread all the way through what will be the final part here when we're done. The threading has to be done before you turn the shoulders, by the way, on all of these parts, because the threading tends to flare out the stock a little bit, so you don't want to turn the shoulders and then do the threading after. You really want to do the threading first. So I flip it around, do the same thing on the other end, and now I've got those threaded holes on both ends. Now I can go over to the collet block in the middle, and now I can make those flat sides as long as I have enough material sticking out here for the entire size of the part. And then for repeatability, I'll put it up against the surface of the chuck there and square that up. Now I can find the center of it, and I'm going to need the end as well, and you'll see why here in a moment. But I'm going to start by creating that flat side. I'm going to mill it all the way down to the right dimension, and I'm going to mill deep enough towards the collet block there so that the entire part will be covered. The reason I found the end of the part is so that I can now drill the hole through what will be the center of this part once it's done. This is going to get tricky later on. It's easier to center a hole on a part than it is to put the hole in what will be the center when we're done, but this is really, I think, the only way to do it, being that the part is so tricky to hold. So now I can center drill, and this hole needs to be reamed as well, so I'll be reaming that. Now, honestly, it would have been more efficient to flip the part over and machine the other side flat before drilling the hole, because once you're set up to drill that first flat, you can flip it over and mill down to all the same numbers on all of your indicators, and you're automatically going to hit the right dimension. But, you know, I got excited to drill the hole and drilled the hole. Look, it happens. This part, by the way, is another cross pin, and this actually acts as kind of like a bushing. It holds the end of the lead screw for the clamping action. So this needs to be reamed so that it has a nice running fit on the end of the lead screw. That hole looks very nice, but of course when we flip it over you can see our secret shame. That's okay though, we're going to be milling off that shame and bringing it down to the same dimension as the other flat side. And once again I'm using the front edge of the vise there for repeatability on the x-axis. And I would have repeatability on the Z automatically if I'd done this before drilling the hole. Look, it happens. A little deburring on everything, and I should also actually deburr the holes here while I'm at it. Might as well, because it's easy to hold while it's still in the collet block. I guess it's just one hole with two ends. Is that two holes? How many holes does a straw have? Discuss in the comments below. And that's looking good, right? You can kind of see the beginnings of our part there. Now, I can flip it around and do the exact same thing on the other end. This is a trick I've shown many times before. It's a great model engineering technique where you're frequently making multiples of very small parts that are hard to hold. You make one part on each end, Bob's your uncle. Now, this would also be a great use case for a collet stop in the inside of a 5C collet. It's one of the cool things about 5C collets. I don't have one, so I had to edge find on the x-axis again to locate the second hole. But once all of those operations are done, you can see how we've got the beginnings of the part on each end here. It's looking pretty cool. Back to the lathe now to put the little shoulder on the end of these parts. Of course, all of these parts have a very precisely depthed and dimensioned shoulder on the end of them to interface with the plates. Everything fits into those plates. And this starts as an interrupted cut because of the flat sides, but pretty soon it is a round cut once again. And that's looking really good. Now I can once again do my finishing cut the same way. Go in, lock the carriage, wind out. All dimensions and finishes are nice. If you want to get a lot of practice turning to a shoulder, this is the project for you. That's looking good, and we didn't have to worry about where the hole is because the hole was measured from the end of the boss, not the shoulder. So far so good. Flip the part around, do the same thing on that side. Now things get interesting though, because it's time to part these off and bring them down to length. And remember, those holes that we made up front have to land exactly in the middle of these parts. So I'm going to part them off, and I'm parting them off just behind the flat area there so that I don't have an interrupted cut on the parting blade. It's not the end of the world if you have to part an interrupted cut, but it's not very pleasant. Okay, so now I can stick these back in the collet chuck, but because of those flat sides, you got to be careful where it lands. You don't want the split lines of the collet to land on the edges of the part there. So I've got to make sure that the flats are spanning gaps in the collet there, otherwise it won't have a good grip. Tighten that down, and now we can face off that round end. So I start by just facing it overall to length, just like you would with any of these other parts that we've made so far. So that involves facing it off, taking it out, measuring, and then doing a final cut to get ourselves to the exact right length. This dimension is critical though. If I don't nail this length, the hole is not going to end up in the center. So there's a lot more riding on the length of this part being right because other features are depending on it to be correct. Now I create the little boss on the end just like before, and if I did my job right, that hole will end up in the center. And that actually looks good. I think that worked out. So 2 of those, and I demonstrated a different way to do this style of part where you need a big hole in the center and there's not enough meat to hang on to. One with a cross drilling fixture and the other by making the parts on the ends of the stock. I've got enough parts here that I can do some test fitting and just make sure everything is going okay. So I've got a bunch of the standoffs between the 2 plates, and I've got the hinge pin in the middle there, and that's looking good. They're starting to look like clamps. I can do some deburring here as I go along and just kind of get ahead of the fitting a little bit. The plates need some chamfering help to make sure the shoulders seat well and all that sort of thing. Everything needs to fit together really tight to keep the plates parallel.
Waka 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 waka.
Longtime viewers will know it's not the first time I've made that joke either. Great progress so far, but that is going to have to do it for this video. I am out of time. So tune in next time for the conclusion of making these clamps. And like I said, I've got an extra one of these kits that you can win. I'm running a contest on my Patreon. There's a link below or in the corner of the screen there. So head on over there to see how to enter to win this kit. It's got all the stock that you need to build these clamps, and it's got all the drawings, build notes, instructions. Really awesome kit. Thank you very much for watching. Throw me a little love on Patreon if you like these videos, and I will see you next time.